Okay, today we're going to go over electron configurations. In order to understand how to create an electron configuration, which is what we'll do in a bit, we have to first understand what is an electron orbital. So let's go back to our building atom activity. Okay, so when we're doing the building atom activity, the atoms we created look something like this, right? The electrons were in energy shells or in rings, but in reality, electrons aren't in the rings. They're actually in what we call, this simulation calls them clouds, but we're calling them electron orbitals. They're in spaces and they're constantly moving. So they're not actually still, but they're just constantly moving. And that this area here represents where they're most likely to be. So the bluer it is, the more likely we are to find them there. The lighter it is, the less. That way, when we add more, it becomes larger because it's a higher chance of finding it there. Okay. So this is an electron orbital. It's just an area where we're most likely to find an electron. Okay. So to answer our first question, what is an electron? It's an area where there is a high probability of finding an electron. So you can kind of think about it, if we were to take a snapshot and if we were actually able somehow to freeze the electron, we would most likely find it there. Okay, so let's go on to our first one, which is our s orbitals. Okay, s orbitals have a round shape, a spherical shape, because there's like a ball. So, and it only has what we call one configuration. If I were to spin this around, it would still be the same shape, right? Okay. So another thing to mention is that electrons can have two types of spins. They can have up spins. So let's say we can have an electron traveling inside of here with an up spin. We can have another electron with a down spin. Okay. So because this can only form one shape, it can hold two electrons, one going up and one going down. So the s orbital holds two electrons. Okay. All right. Okay, let's go ahead and move on here. Now we move on to the p orbital. The p orbital it's like a dumbbell shape. So if you have this shape, we can actually go here. We can have it this way in the x-axis. We can have it going up in the z-axis, or we can have it going like away from us and to us, right? So there's three different configurations. Each configuration can have an electron with an up spin and a down spin. Up spin, down spin, an up spin, and a down spin, right? So in other words, each suborbital here can hold two electrons, two here, two here, two here. So p orbitals can hold 6 electrons. All right. So that's kind of the reasoning behind it and why it happens. Now, f orbital, same thing. We have 1, 2, 3, 4, 5. You see the shapes get a little bit weirder. So all we really have to remember is that the d orbital has these odd shapes. But since there's 5 of them, each of them can hold 2. 5 times 2, my d orbital can hold 10 electrons. And then last of all, my f orbital has weird shapes, so we're not going to go over it. But just know that it has 7 different subshells. So like this, but 7 different of them, and each one can hold 2, right? So my f orbital can hold a total of 14 electrons. Okay. And again, orbitals are just where we're most likely to find an electron. They have different shapes. Okay, so let's go ahead and clear this. And we can have different levels, which we'll go over in a bit. Let's kind of summarize this. Okay, so my s orbital can hold an up spin, a down spin, so it can hold 2 electrons. My p orbital can hold, actually, switch color here, has up spin, down spin, up spin, down spin, for a total of 6. So p orbital can hold 6. Okay, my d can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and 10. It can hold 10. Okay, and you guys kind of get the point. I won't draw all of this, but it'll be the same. It can hold 14. Okay, so that's 7 shells, and it can hold 14. Okay, now let's go over what we call the off-ball principle. This principle basically states that the lower energy shell, or the lower energy orbitals, are filled before the higher energy orbitals. Okay, and when we're talking about high energy and low energy, as we go down here, our energy goes up. Okay, so our energy goes up. So these are high energy, these are low energy. Okay, so all that's saying is that we can't fill the p orbital before I put electrons in the s orbital. So we have to go s orbital, fill that up, then we go to the p orbital, then we fill that up, d, and so forth. Okay, you can't just start at the p orbital. Okay, so what's the order in which these are filled? So the order in which these are filled is we start with our 1s orbital. We fill up here, then we fill up to our 2s, 2p, and so forth, all the way to 7p. Okay, so you can try to remember this, but it's probably a little bit too difficult, too long. I'm going to give you a way that we use the periodic table to figure out which electrons are in which orbitals for every element. Okay, so I'm going to go ahead and clear this here, and let's look at a periodic table. So in the periodic table, we actually have different groups. We have what we call the S group here, the D group, and the P. Okay, so everything here has electrons in the S orbitals. Everything here has electrons in the D orbitals. Everything here has electrons in the p orbitals. Okay, and these are the Fs, which we won't go into too much, but you will have a few problems on. Okay, so that's what orbitals are. And in the next video, you're going to go over how to write electron configuration.